All right. So yeah, let's just get into it. Let's just get into it. So a little bit about me. I've been obsessed with blockchain since 2017. This is around the time, if you remember, Bitcoin went from $1,000 in January to about $20,000 by December. That to me was ridiculous. So I decided to like research what exactly Bitcoin was, what exactly this blockchain hype was about. And little did I know, I would spend the rest of my life researching blockchains. So yeah, let's keep the slides going. Let's keep the slides going. So and also around the time when I started working researching on blockchains, I also started doing Rust open source. So I've also done a little bit of mobile development with React Native at the time, but I didn't want to spend my whole life writing React Native. I wanted to do systems engineering. I wanted to code low-level programs for all kinds of applications, IoT, big data, whatever. So I picked up Rust in 2017, and then at the end of 2017, I decided, okay, maybe I can apply Rust to blockchain. So let's keep going. So, of course, this is open source first. I did a lot of open source around 2017. Let's keep going. Um, and so little did I know that all my open source Rust actually would be instrumental in me getting a job at Parity. Actually, how I got the job was very funny because usually I'm on Reddit, on the Rust subreddits, and people post their, the work that they're doing, maybe some open source library, some really, really nice uh, code that they wrote. And Parity posted, hey, look, we're looking for Rust developers. Come work for us. We're doing blockchain. I applied in July and I got in September. I actually got to speak with Gavin, who was the founder of Parity at the time. He's the co-founder of Ethereum, for those of you who don't know. And actually, I didn't really know who he was at the time. I just knew I wanted to do blockchains. So let's keep going. So my time at Parity was spent on the Rust implementation of Ethereum. For those who know, Ethereum is currently written in Go. That's the official software maintained by the foundation. But Parity had their own implementation. I mean, anyone can write an Ethereum implementation. I think there's even a JavaScript implementation if you feel like contributing to that. I also worked on Substrate, which is a blockchain framework in Rust, as well as the Polkadot network, which was built with Substrate. So let's keep going. So I spent roughly 3 years in Parity where I decided, okay, I've worked on infrastructure enough. I want to see what it's like to build applications with this infrastructure that we've worked on. So I started Polytope Labs in 2021 after leaving Parity. And the rest is history. So what about Polytope? Let's see, what does Polytope do exactly? Next slide. Next slide. So Polytope Labs is a blockchain research and development lab. And I know you're probably asking yourself, okay, what exactly are you researching about blockchains? Well, keep going. Well, our research areas include things like cryptography, next slide, blockchain protocols, and ZK proofs. So keep going, next slide. Next slide. Yes. One more. So our research is actually funded by the Web3 Foundation and the Polkadot Treasury. So the Web3 Foundation is kind of like the Ethereum Foundation, but for Polkadot, as well as the Polkadot Treasury. And you can think of the Polkadot Treasury as the sort of funds that is held by the network. So people who own the dot tokens can vote on how to spend these funds. So they funded some of our research areas, and we're glad to be, of course, one of the recipients of their grant funding. Let's keep going. So if you're interested in the kind of problems that we tackle, the kind of things that we're thinking about, you can just check out our research website and yeah, go crazy. So next slide. All right, so the title of this talk is Breaking into Protocol Engineering. But why would you be trying to break into protocol engineering in the first place, right? I thought we could just write Solidity and be happy and upload our ERC20 contracts and sell meme coins. Not really. So those of us who are blockchain engineers here know that blockchains are not scalable, for instance. So let's next slide. Let's go to the next slide. Next slide. Next slide. So yes, blockchains are not scalable. Those of us who are also in the space will see that there's this blockchain scalability trilemma, right? You either have to sacrifice two things to get one thing, yada yada yada. You know how that goes. So most of them are not really scalable. People will claim Solana is scalable, but you can't run a Solana node on your laptop. You need to run it in enterprise grade servers. That's not really scalable. That's just a database at that point, right? So let's keep going. They lack privacy, and I think this is one of the most critical parts of blockchains that make it not ready for mass adoption, right? Imagine if a company wanted to hold their funds on the chain. Now, all of their competitors can see how much they have and can, of course, just go raise more money and beat them out of the market. So we need privacy, and not just for companies as well, but just for like individuals on a daily basis. I don't want to have to send you money and then reveal my entire balances to you, right? This is a problem. This is a real problem, actually, and there's lots of people who are working on this problem. So let's keep going. Of course, everyone's transaction histories are entirely open source. Let's keep going. Now, this is another issue that's more nuanced, but you'll start to see why it's a problem. If we think of blockchains as nation states, right, you have the Polygon network, which has a lot of users in India. You have, let's say, the Binance chain, which has a lot of users in China. You have maybe Optimistic and the Arbitrum networks, which have a lot of users in the US. If there's no way for all of these networks to talk to each other and value to move across this network, then we just started with the problem. We just go back to the problem we started with, which was how can we make value move across countries seamlessly? So blockchain network interoperability is also a very critical feature, and not a lot of people are thinking about this. So let's keep going. Of course, yes, users should be able to move across blockchain networks seamless. Let's keep going. Next slide. So today, in my opinion, blockchains are like the early browser. Imagine when we had HTML 1.0, right? You wouldn't be trying to build a very complex HTML game on the browser. No. Where your attention is needed the most is in building the browser itself so that it can become robust and scalable enough for it to be used by everybody. So let's keep going. Of course, I already said this. So there's a lot of more work to be done at the base layer. Next slide. And what that really means is that there is more opportunities at the base layer. 8 years of smart contracts, and what have we gotten? DeFi, NFT, and all kinds of Ponzi, right? So next slide. Next slide. So if we really, really take a step back, close our eyes to the noise, close our ears to all of the hype, what has blockchains given us? Simple, seamless value transfer. I can send money to anywhere and anyone anywhere in the world. Beyond that, it's not clear if there's any other powerful application that blockchains have. So next slide. And of course, Nigeria needs crypto. We're one of the highest ranked people who adopt crypto the most. And this is beyond other third world countries across the map. So we need crypto. And if we're not the ones who are building this infrastructure for crypto, then it turns out that our Web3 scene will look a lot like our Web2 scene, right? All of our Web2 tools will be imported, and all the value and wealth that is created from us using these tools are exported. We need to switch from being just consumers to becoming builders. So next slide. Next slide. So even more especially, we've been locked out of the global financial system, right? Remember, just a few months ago, all the virtual asset card providers were locked out. This is not a coincidence. There is an agenda to keep Nigerians locked out of the system, right? If you try to send money to a Nigerian DOM account, your bank will block that transaction from anywhere you are in the world. This is exactly why crypto exists, to break down these borders that have been built to lock some people out of wealth. So next slide. I mean, of course, this is the case. We need better. Next slide. So crypto enables radical financial inclusion. You know, the blockchain will not say, oh, look, you're black, you can't send money. Or look, you're white, you can't send money. It doesn't care. It's just code. No longer are people in the middle of value transfer. It's just computers. And computers don't really care. Next slide. So, in my opinion, crypto will be the critical infrastructure for the next generation of financial services. Imagine where you are saving your money and that money is locked in some DeFi protocol and you earn rewards for your money. Your money is not custodied by anybody like SPF who can steal your money, or maybe like, you know, all these new crypto exchanges that are actually, you know, consuming their customers' funds and not really giving them value for it. So next slide. Next slide. So I want you to take away from this section that we should be the ones building this infrastructure. We should not be consumers of crypto, especially because crypto is early. Remember, it's early. And because it's early, we can make significant contributions to the infrastructure. So next slide. So protocol engineering. Now you are interested in, okay, how do we build this infrastructure? What do we need to know? What are the things we need to learn? Let's look at them. Next slide. Protocol engineering, unlike dApp development, and smart contract development concerns itself with infrastructure level problems. So things like consensus algorithms, my man here mentioned proof of work, proof of stake, yada yada yada. We will now be the ones designing these new consensus algorithms depending on our use cases. Because every blockchain can have a different use cases. You might want a use case that is focused on payments alone. You don't need to have a very complex consensus algorithm in that case. You can design a custom-made consensus algorithm to give you the fastest payments network ever, right? So things like interoperability, things like privacy, things like applied cryptography, and then blockchain client implementation. So as you know, blockchain is just software, right? So we need more people who are working on every intersection of these problems. So let's keep going. Let's keep going. So, of course, distributed system and consensus, things like proof of stake, proof of work. If you're interested in Ethereum, Ethereum uses Casper FFG. For instance, Sui, Aptos, they use this new mechanism called Narwhal and Tusk. These are all the words I want you to become familiar with, know how they work, and be able to even replicate them if you need to. Let's keep going. Applied cryptography. So things like hash functions, Merkle trees, digital signature algorithms. These are the things you need to understand how they work. I'm not saying you need to know how they work internally, but at least you know how they behave. You know how to use them. You don't know how SQL works inside, but you know how to use SQL. So this is how your relationship should be with these things. So let's keep going. So zero knowledge proofs, and I know they sound very, very scary, but I promise you they're not. They allow you to hide information, but still preserve the authenticity of this information. And we'll look into how this works later on. Let's keep going. So virtual machines, if you want to be able to program your blockchain, EVM is not the only virtual machine. We also have WASM. We also have eBPF. We also have Risk Zero. These are all different kinds of virtual machines that I'm sure most of you haven't heard of, but you will need to become familiar with how they work. So let's keep going. Of course, P2P networking and DHT. So DHT just means digital. They are chasing me away. Do you guys want me to go? If you want me to go, I'll go. They don't want me to go. Let's keep going. So digital hash tables. This is just how you model a peer-to-peer network. So something like BitTorrent, for instance, if you've ever downloaded a torrent, you will notice that you're downloaded from multiple people on the network. So a DHT is how you model this relationship and how you get this data from all these different decentralized peers. So let's keep going. And then the final thing is mechanism design, game theory, and economics. And yes, this is a very, very broad set of topics that a protocol engineer needs to be conversant with. But I promise you, when you combine all of these things, you get what is basically an uncensorable and unhackable network. So let's keep going. So breaking into protocol engineering, how exactly do you now become a protocol engineer? Let's keep going. Let's keep going. Well, you will need to have some tolerance for math. I'm sorry, but it's just the truth. Now, I didn't say you have to know math, like you have to be some sort of PhD level in math. No. All you need is to be able to read math. Just the same way you're able to read code, and you can understand what's happening. You can understand, okay, this code is supposed to do this. You should be able to look at some mathematical notations and be like, okay, I understand what this math is saying. Wow. Are you guys serious? It's almost the end. It's literally almost the end. All right. Um, if you guys would like to learn more about protocol engineering, you can check out our Twitter, Polytope Labs on Twitter. Follow us. We have a protocol guild coming up, which is like a community for people who want to be part of the protocol engineering space. Come together, share notes, share what you're learning, and basically help each other along your journey. Thank you. I'm very